Hi Prof, we are IDORGuard from P1BG4 and our project is about broken access control, insecure direct object reference or IDOR in short. My name is Jie Fong and this will be our agenda for the day. And this is our project session responsibilities. So for introduction, we'll be giving a bit of background. What is IDOR? IDOR is a type of broken access control which was ranked as the top security risk in the OWASP top 10. It also stands out as a persistent issue in broken access control category, which allows bad actor to have horizontal or vertical privilege escalation. Our project is to implement an exclusive scanner specifically for IDOR on a web application. So this is the existing research related to IDOR. First, we have the GitHub repo from this user, which compiles the top IDOR reports from HackerOne, and one of the most notable case involve PayPal, where business account owner can add secondary user from non-business account, thus granting the non-business user exclusive functionalities in the web application. Next, we have research on penetration testing with IDOR method, which demonstrate the use of Burp Suite to scan and exploit IDOR vulnerabilities. Lastly, we have research from Smith and Lee, where they compare various access control model and found that basic role-based access control often fails in modern application, thus proposing a integrated attribute-based access control into traditional role-based access control. So this offers a better approach at reducing IDOR risk by better segmenting users' role from resources. All these researchers shows how prevalent IDOR is, thus motivating us to work on this IDOR guard scanner. Now I'll be handing over to Mustaq to talk more about our project.
Hello, I'm Mustaq. I'll be going through the objective, purpose, and methodology of IDORGuard. One of the key questions we wanted to explore in this project is how can a targeted vulnerability scanner improve the detection and mitigation of IDOR vulnerabilities compared to our general purpose security tools like Burp Suite, AIR, or WASP-Z. So our goal was to create IDORGuard, a program that audits websites for insecure direct object reference or IDOR vulnerabilities. The purpose of our project, firstly, is to address critical security risks. Broken access control is the number one risk in OS top 10, and IDOR is a persistent issue within it. Our tool directly addresses this threat. Secondly, an automated and efficient IDOR detection. Instead of manually security testing, IDORGuard automates the process, making vulnerability scanning faster and more reliable. And thirdly, a proactive security for developers. By helping developers identify, analyze, and fix IDOR vulnerabilities before they are exploited, we enhance the overall security posture of our web applications. So, now for our methodology of IDORGuard. IDORGuard is built on three core components: the crawler, fuzzer, and analyzer. The crawler traverses the web application to identify endpoints and extract parameters for testing, while our fuzzer systematically modifies object references in URLs and API calls to test for unauthorized access, while our analyzer compares server responses to detect access control failures and logs the findings. One of our key improvements over existing tools is our enhanced API detection, which identifies API endpoints from inline JavaScript and tests them for IDOR vulnerabilities. Now I'll be talking about how we used web crawling. Our IDORGuard's web crawler is built using JSON, allowing it to parse web pages and extract links, identify forms, input fields, and parameters, and also recursively follow links up to a user-defined depth for deep scan. For our IDORGuard vulnerability testing, our IDORGuard extracts URL parameters and checks them against a predefined sensitive parameter dictionary, while it also iterates through a customizable ID range, example from 1 to 500 to detect unauthorized access. It also tests hidden API endpoints using get, post, and put requests with modified object references. One of the key innovations of our IDORGuard is its ability to detect API endpoints. As said earlier, this tool scans inline JavaScript for dynamically constructed API calls, identifies fetch requests, and tests them for IDOR risks. For our reporting and logging, IDORGuard displays real-time results in its GUI interface, exports detailed CSV reports categorizing our vulnerabilities into form-based, API, and parameter IDORs. It also provides recommended mitigations to help developers quickly address the detected vulnerabilities. To validate our IDORGuard's effectiveness, we deployed it on a controlled test environment with deliberate IDOR vulnerabilities. We also compared it against OWASP, ZEP, and Burp Suite based on three key evaluation metrics. One of it, which is detection accuracy, measuring our false positives versus true positives, our execution speed, analyzing performance when scanning large datasets, and finally coverage, which ensure both front-end API-based IDOR vulnerabilities are detected. Now I'll hand over to Aaron Chan to talk about our findings, results, and demo. Thank you.
Hi, I'm Aaron and I'm presenting about the findings, results, and demo. So here is our IDORGuard GUI. It has 5 fields and 3 buttons. First, you have the URL. This is where you input the URL of the web application that you want to check for IDOR vulnerabilities. Username, password. This is for logging into the web application with the login button. Depth. This is how deep the crawler will go. Starting position, this is where the user wants to test for the IDOR vulnerability. So let's say if your first user in the web application is actually user ID 101, you can start from 101 instead. Then number of rounds, this is to test for IDOR vulnerabilities from the starting position plus minus from there. So if let's say your starting position is 10, number of rounds is 10, you will scan from 1 to 20. If let's say your starting position is 1 and the number of rounds is 10, it will go from 1 to 10. It doesn't go below that. So next we have the login button. This is to sign in if there is a login form at the URL. Start crawling button will basically crawl the web application to check for the IDOR vulnerabilities. That is your main button. And then there is an export log button, which will export the detected IDOR vulnerabilities into a CSV file and give recommendations. So basically, this is how instructions of how the crawling works. So you basically enter the URL you want to detect for IDOR vulnerabilities and click start crawl. If let's say it detects a login form, you can fill in the username and password and click on the login button. Once successful, you can begin to crawl again, as you can see. IDORGuard have 3 functions. First is to find IDOR vulnerabilities in forms. If you can see, basically there's on top there you can see it's an unnamed form. It found a user ID inside it. Next, we have test IDOR vulnerability in the URL, which is the second whole chunk of section there. That is basically testing for IDOR vulnerability in the URL. And at the last chunk, testing at the bottom is basically testing for our IDOR vulnerability in the API. So how it detects for IDOR vulnerabilities, we use a dictionary called parameter.txt. As you can see in the URL, there it contains the parameter user ID. Yeah, IDORGuard will check for that parameter in the dictionary. So if it has it, the function can test for IDOR vulnerability on it. If it does not, not to worry, you can just add a parameter into the dictionary and run it again. So once you're done crawling, you can click the export log button and it will generate a report for you. You'll generate a CSV report with detected IDOR vulnerabilities and recommendations. So here we have is our demo. We are basically testing on the web application test2214. As you can see, there's a login form here. So if we start to crawl, you can detect that there's a login form. So if we type in the username test user with its password, login successful, which is basically this person here. And as you can see in the URL, it says user ID equal to 1. So there may be a IDOR vulnerability. So we set our starting position to 1 and the number of rounds 10. So if we start to crawl, it will crawl from 1 to 10. Okay, so we got find a user ID inside the form. There may be IDOR vulnerability inside the form, and then the possible IDOR detected at user ID 2 and 3, and possible API IDOR detected at user 1, 2, and 3. So if we try to change to 2 here, you can see that our username changed to test user 1. And now we can export the log, which can be found in our IDOR report. So basically, it will collate all the IDOR vulnerabilities here and give a recommendation.
Thank you, Aaron. So I'll be talking about the analysis and discussion of our project. So before I jump right into it and everything, I would like to showcase our website, a website that we have developed our own to showcase the IDOR vulnerabilities, and so to show how our solution is able to pick up on such the IDOR vulnerabilities. So as you can see here, in the URL, for example, there's a typical that is user ID, and it can be shown here. More so whenever a user login, this is what they will see. We simulate some typical things like updating your passwords and using the API to do such sort of things. Here is the source code, but a bit jump out, so I will highlight some certain things. Some in the fields, for example, are very typical ones that in the field there will be a hidden value such as for your user ID right here as well. And so our solution allows for it to pick up on these kind of things. So as I'm previously taking back the screenshot from Aaron, again, these are what we are able to find. Bringing back the screenshots as well, let me highlight all these things again. Our IDOR solution is able to pick up on these such of values or hidden fields right here, these kind of things, just to show. So this is just to showcase that how our solution does work. It does pick up on these kind of things. But though on the surface, but even API we included on the forms we included in such. Here is a table of the comparisons between all the other typical solutions such as Burp Suite or SwapZap compared to our IDORGuard. So as you can see, the major categories going is detection on the URL, at the API, whether we can customize on the dictionary, reports, login mechanism, etc. And the pricing as well. For us, we are pretty free. So as you can see, some things I like to highlight. Some that are all the other solutions can see in the URL. The one things that we like to highlight as well is the API. Some solutions do not. Some solutions do have it as well to check the API. But like I say, SwapZap there, it does not. It's limited there. We also like to highlight ours that we have a customizable dictionary. As Aaron has mentioned, we have a parameters.txt that allows us to search for certain things. So it's very customizable for other websites. Say they have a certain type of naming and you can customize it based on that, and we have reports and everything. Moving on, I'll talk about the impacts. One will be security improvement, preventing data breaches, time saving, and awareness of security gaps. Now all these are quite very important. At least our solution allows it to have a typical scan through your website or anything. It helps to improve it, helps to prevent any data breaches that we easily can find for it. And it is time consuming because once you can just log in, click onto our solution problems, and it will do all the scanning for you, and it allows you to see whether the gaps that you may or may not have missed. And so this is the 4 impacts that our solution allows for it. Next, I'm moving on to the benefits. One would be comprehensive testing. So of course, when you're testing it or your website or anything, you check all the parameters. Again, at the API standpoint as well, is crucial for modern applications, which also relies heavily on API. So ours, at least when it checks the API, is good for these kind of big applications. Automation of vulnerability detections, we allow it. This tool helps to detect these vulnerabilities, limiting the need for security professionals to manually test and check line by line painstakingly for it. So for us, at least, it's a scanner that it helps to immediately scan for it. ease of use as well. It is a very user-friendly GUI. It allows for it to just run it. You can just key in the particulars of for you logging and just simply run it. And we have a report, so it is to allow it to, it makes it easier for security teams to track down and document all these kind of security reports, and that's what a feature that we have put in. So it is very easy, especially for security team to discuss or tell to their stakeholders or everything. At least they have documentations for it. Next will be customization and flexibility. As I mentioned, we had a parameters text that our dictionary, and it allows for very customizable depending on the type of website or large applications that you are trying to scan for. Next, I will hand over the presentation to Jia Fong. He will talk about more of the ideal tools also. Thank you.
Based on our research and ideation, this is the ideal IDORGuard scanner that we have come up with, which has three main components. First, we have the crawler. This component will systematically dig the web application and find existing endpoints and parameters that might expose direct object references. Ideally, it should handle multiple user roles like admin or user to test for every access level for potential IDOR vulnerabilities. Next, we have the fuzzer. After the crawler identifies the endpoints and parameters, it will proceed to modify the object references, for example, alphanumeric strings or special characters, which will catch IDOR vulnerability in an application that uses a more complex references rather than simple numeric values like user ID equal 1. Furthermore, the fuzzer will learn the object references dynamically from the web application itself, thus improving the fuzzing capability in the long run. Lastly, we have the analyzer. After scanning and trying to gain unauthorized access to other users' resources, it will compare the fast response against the baseline request, and if it detects unauthorized data exposure from the fast response, we will flag it as a potential IDOR vulnerability in the log. Ideally, this component should also simulate multiple user roles, which allow us to see if access control are properly enforced on each level. And it also allows user to export the log into Excel file. For our current tool, due to time constraint, we are unable to fully implement what we want as proposed. For example, the crawler successfully finds existing endpoint and parameter, but it only simulates for a single user and not multiple user as intended. Next is the fuzzer, which compared to the ideal tool, it takes in a fixed dictionary which consists of common object references like user ID or account ID, and then add a equal suffix with increasing sequential numbers at the back. This only works if the application uses common words and sequential numbering, thus it is limited in scope and will not learn dynamically. Lastly, the current analyzer could not fully simulate role-based testing, which tests for multiple user roles at once, and the logging details are straightforward, as it only logs possible vulnerabilities but not advanced analytics or multiple role insights. Despite the differences between the ideal tool and current tool, IDORGuard still offers valuable exclusive IDOR scanner, which will be improved in the future. Next, Yong Yao will be talking about IDORGuard's limitation and future improvement.
Hi, I'm Gong Yao, and I'll be presenting the limitations and future plans of IDORGuard. While IDORGuard offers valuable insights into access control vulnerabilities, there are still some limitations that we need to address. Firstly, it's its heuristics dependence. IDORGuard uses predefined parameter dictionaries to detect IDOR-related vulnerabilities. If certain sensitive parameters are not included in the dictionary, it may fail to identify some vulnerabilities. Next is its authentication challenges it can face. While IDORGuard supports login-based scanning, it may not work as well with websites that implement strict session handling, multi-factor authentication, or token-based access control mechanisms. This limits its ability to test applications with advanced security measures. Lastly, the tool's API parameter extraction. Currently, IDORGuard only uses regular expression, aka regex, to extract API endpoints from JavaScript. Some modern web applications use advanced JavaScript frameworks and obfuscation techniques. making it difficult for IDORguard to extract the API endpoints. To solve these limitations and further enhance IDORguard, we have chosen several key areas for improvement. First, dynamic learning. By integrating machine learning, IDORguard can analyze past scan results and adapt to application behavior. This will improve detection accuracy and help identify any new vulnerabilities. Second, broadening its scanning capabilities. We aim to expand IDORguard to detect additional vulnerabilities such as SQL injection and cross-site scripting instead of only scanning IDR vulnerabilities. Third, role-based access control simulation. IDORguard will incorporate role-based access control, aka RBAC, testing to simulate different user roles and detect unauthorized access. Fourth, an improved dashboard with user-friendly interface that includes visual analytics, filtering options, and better report formatting. Fifth, advanced evasion techniques implementing rate limit evasion, such as request throttling and session rotation, which will help bypass security restrictions and improve vulnerability detection. Finally, an improved JavaScript parsing. We plan to replace the basic regular expression-based extraction with an extract syntax tree parser or a headless browser to analyze JavaScript code more accurately. These enhancements will make IDORguard a more powerful and effective tool in identifying and mitigating security risks. To summarize, IDORguard automates IDOR detection through web crawling, parameter manipulation, and API scanning, making security testing easier and more accessible to developers and professionals. It also helps prevent data breaches by identifying access control flaws early. And its future enhancements will improve accuracy, expand coverage, and enhance usability. That is all. Thank you.